Hi, I'm Sheila Brennan, and today I'm going to try to convince you why you should prototype it. Well, today I'll be focusing on web. The concepts I'll be covering apply just as easily to other platforms. First, a little bit about me. I'm a front-end engineer, formerly worked in DevOps. I love tinkering with CSS, and I infrequently blog at sheilab.com. So why would I prototype it? Well, maybe you just heard back from a product manager you're working with a message like this. Or maybe you just heard back from a designer that you're working with on a key project with this. So, what are some specific cases where you might want to consider prototyping it? Well, one is to start building out more complex interactions up front, even before the final comps are ready, just to figure out exactly what's possible and to also get a leg up on whatever the problem areas are. And it also allows you to get early feedback on what you're building. Another reason to prototype is to figure out the best way to build a series of animations that you're adding for a new feature. By building it in isolation, it's much easier to focus on the animations themselves, how the best way to build them is, and to make sure that they're smooth and performant. Or maybe you just want to prototype it to explore the possibilities of a new tool or framework that you haven't used before. You might discover a new favorite. So now you might be asking, how should I build a prototype? I normally opt for online tools like CodePen. There's also Code Sandbox or JS Fiddle. There's plenty of tools out there. It's most important to find one that you're comfortable with, and if that for you is just to build something on your local machine, then that's what you should go with. Something to decide up front is the level of fidelity that you need or the level of detail for your prototype. I highly recommend going with low fidelity if you can, and then you might have to go up to mid fidelity if you're going to be sharing your prototype with a wider audience that needs to see more detail to understand what the final product may look like. And now it's demo time. Here's some examples of prototypes that I've built. This first one was to figure out how to build a group of animations that were starting at different times, involved change in background color, changes in SVG positioning and fill color, and some swapping out of PNG images as well. This one was for a menu interaction that we needed in a new app. And by building this separately as a prototype, I was able to get feedback from the designers early on, and it saved a ton of time when it came time to integrate this into the app. This is an example of a prototype for a navigation menu. There was a lot of changes at different screen widths in layout and animation needs, and by building this out up front, I was able to get some great feedback from the design team. It saved a lot of time later. And finally, one in the just for fun category. I built this out when I was first experimenting with Vue.js, which is a JavaScript framework. I just wanted to see what it was like and to try out also at the same time some CSS animations. Finally, some takeaways before we wrap up. Keep it simple. Unless you really want to dive deep, it's all up to you. Start small and you can always build on what you've started with and add more detail or functionality if needed later. Remember that this is throwaway code. It's more a proof of concept or to get feedback from a wider team. You can always improve on the code or throw it away and start over when it's time to make something production ready. Most importantly, have fun.
Usability testing is a powerful technique that helps us build better sites, apps, and other products using a scientific approach to design.
Hi, my name is Lexie Martin, and I'm a designer and a user researcher.
To me, usability testing is one of the most valuable tools that I have as a designer, and I'm excited to share this short crash course on the topic. There's a lot of confusion and mystery around the idea of usability testing. To most people I meet in tech, usability testing is something they've heard of but still have a lot of questions about. What exactly is a usability test, and what do you need to conduct one? Here's my definition. Usability testing is a research technique that observes how people interact with digital and physical products. Through research, we can learn what features are most useful to the people we're designing for. Usability testing is also a great way to discover the flaws in sites and apps before anything ships. Here's a shorter version of the definition of usability testing. Usability testing is how we build better stuff with science. Why is usability testing helpful? Tech teams can often get caught up in their own ideas and assumptions. As a team, we might think we know exactly what our customers want. We also might feel pretty sure that we built an error-proof app. In many cases, data has a better idea. When you let real people loose on your product, you can learn a lot about how to improve what you've created. How do you get started with a usability test? As soon as you have a live product or a prototype that you can use, you're ready to start recruiting your research participants. You can learn a lot from a small group of testers. 3 to 5 people will work. Try to make this group as representative as possible. If you can, recruit test participants from your user base. Step 2. Compensate your participants appropriately. When in doubt, pay cash. Gift cards are also a good incentive. Step 3 is to write tasks for your usability test. Before you begin testing, figure out what sections or features need to be observed. Then, write out prompts that will lead participants to interact with that content. We call this writing tasks for a usability test. For example, if you're testing a retail app, write a short task where you give the participant a type of item to search for and a set budget, just like they would do if they were really shopping for something. Now you're ready to conduct the test. Introduce yourself to the study participant and explain the purpose of the test. If you have the participant's permission to record the session, video and screen recordings of usability tests are helpful to review later. Before you officially begin testing, encourage study participants to think out loud. Tell them to read aloud as they go, to share any comments, and also to describe what they see. It can feel awkward to tell a stranger to voice every thought that comes into her head, but offhand comments in usability tests often contain priceless bits of data. Be prepared to be surprised by your study participants. A feature that your product team thought was easy to use may turn out to frustrate someone who isn't familiar with it. The language your marketing team thought was fun and fresh could turn out to confuse potential customers. In order to get the best results from a usability test, it's a good idea to have the test be conducted by someone who is able to be impartial and objective about the results of the test. Here are a few more tips to help you out as you conduct a test. Number 1, listen carefully to what your study participants say. Don't feel the need to talk just to fill the silence. Number 2, if you need to clarify something that a study participant said, it can be helpful to just repeat one of the things that he or she recently said as a question. Tip number 3 is to ask follow-up questions when needed. Small and specific questions can be asked while a participant is working on a task. Longer or more open-ended questions should typically be saved until after the task is complete. As you become more comfortable with conducting usability testing, you'll develop your own strategies for getting the most valuable data. I hope that this crash course has helped you feel a little more ready to dive into better design through science.
Hi, I'm Sarah Bates, and I'm the CEO and co-founder of a digital health startup called Mamament. Before starting my company 2 years ago, I was a data scientist and engineer. And that transition from a technical role to startup founder and CEO has been challenging. Rewarding, but definitely challenging. So what I'm going to share today are some of the lessons I've learned along the way. It's basically what I wish someone would have told me before I started this crazy journey. For some context, I'll start with sharing a little bit about who I am and how I got here. My background is pretty technical. I have an engineering degree in operations research from Cornell and a master's in information systems from Northwestern. Being technical and good at math have always been a big part of my identity. I also always knew that I wanted to be an entrepreneur. I ran a machine learning consulting company before MamaMend and worked primarily with startups. While helping them build and implement models to better serve their customers, I learned about the challenges that would come up. And at the same time, I was brainstorming interesting startup ideas. And then I got pregnant and had my first kid. And as a result, I found a problem that really stuck with me. And that problem was that new mothers are in the dark and aren't getting the help they need to recover from childbirth. And that leads me to lesson 1. Lesson 1, keep it simple. As engineers, we love engineering solutions to problems. But not every problem needs an engineering solution. Sometimes a simpler solution is better, especially to start. When I first started MamaMend, I envisioned this full-featured app that would do all these things, collect a ton of data, make a ton of predictions, automate everything, and it would be amazing. But there's a chicken and egg problem. In order to build a product that uses data and models, you need to have users to collect data from. And in order to have users, you need to already have a product. So eventually, we figured out what people actually need. In our case, they need to know what's normal and what's not, and they need an easy way to connect to specialists. So that's what we're doing. And eventually, if we can add some cool bells and whistles, then great. But for now, we're just happy making something that people need. Lesson 2, outsource as much as possible. Related to keeping it simple is not building everything custom. We made the mistake of building our whole website from scratch from the start. We thought, tools like Squarespace are for non-technical people. Wrong. These tools are for people who need to move fast, which is every early stage startup founder. Speed is incredibly important when you're iterating to find product market fit. And even if something custom is way better, to start, you should still use the fastest thing. The exception is for whatever your competitive advantage is. So if your product is some software that does something no one else does, then yes, build that in-house. But everything else, outsource. Eventually you can build custom, but that's after you know you're building the right thing. Lesson 3, be comfortable with the uncertainty. So it's no surprise that startups are full of risk and uncertainty in a big picture way. But what I didn't realize is that even the little day-to-day things are full of risk and uncertainty. As engineers, we get accustomed to instant feedback. Your tests pass or fail, or your model accuracy goes up or down. You get instant measurable feedback all the time. And that is not always the case as the founder of a startup, especially in the early days when you don't have enough users to do A/B testing. So you have to get comfortable doing things without knowing if it's going to work. We decided early to invest in a content marketing strategy, knowing it would take time to see results. For us, it took 15 months. Lesson 4, recharge so you can keep going. Know where you get your energy. There's a lot of literature out there on introverts and extroverts, so if you fall neatly into one of those boxes, you know what to do. You just have to schedule in that recharging time. However, I've never known which one I am. I just learned about the term ambivert, which basically means both. So if you're an ambivert like me, you might need to learn by trial and error how you can recharge. I learned the hard way. After 7 back-to-back initial sales meetings in one day, I need a walk. Lesson 5, remember your worth. Going from an expert in your field to being just okay at a lot of different things can be really tough on your self-confidence. Keep in mind 2 things. First, you don't have to be an expert in everything to succeed. In fact, it might actually be better to be just good enough so you can find your fanatical first customers that don't care whether your website looks amateur or your sales pitch isn't the most polished. They're just thrilled about what you're building. Second, you probably will become more of an expert than it feels like. So find people who boost you up and remind you that you're awesome. I'm very lucky to have an amazing network of brilliant and kind people that I respect and that respect me. Without them, it'd be a struggle. So those are 5 of the important things that I learned from the journey from technical to CEO. I hope that you remember them when you go on to build your own company.
All right. Hello, everybody. I'm excited to be here at Google Developer Group as part of the Women Techmakers. Without further ado, I'm going to jump right in because I only have 5 minutes to complete my lightning talk. Today, I will be covering Code More Faster, which will focus on 5 tips that will help you build software as quickly as possible and ship. So my name is Madison Susie. I'm a founding engineer at bookclub.com. We make a consumer application that lets you interact directly with the author of the books that you're reading. And I've been a long-time observer of the balance between quality and speed in software. In my career, I've spent most of my time in startups and in innovation teams in larger companies. And this is a question that comes up relatively often about the quality of the software that we should be building versus the speed to ship it. So in this talk, we'll be covering some of the things about how to build as quickly as possible and focusing on that side of the balance. So imagine us tipping the scale really severely towards speed. And in this, I will be kind of using the anecdote of Techstars Studio, which was a piece of software, a platform that I built last year. And it was a piece of software that we built really, really quickly and focused on speed. So quick recap of what that is. It is a portal meant to be used inside of the Techstars network, so for founders who have gone through the Techstars program and who potentially have other ideas of companies that they may want to start or may want to join new companies. So we built a platform that allowed these founders or other people in the network to go ahead and add their ideas to the platform and have other people inside the network collaborate on those ideas and potentially even join and create a founding team. And we were tasked to do this in 10 days. Now, we were able to push back a little bit on that deadline and we're able to negotiate with the business unit and get it to 5 weeks because we were starting from ground zero and we're able to launch it in that 5 weeks at Techstars Summit. So like I said, we had the deadline set ahead of time and we needed to execute and get the features out to our users for that launch. So we'll be covering 5 quick tips on how you can launch an application in 5 weeks or less. So first, focus on shipping and outcomes. This is critical. We had the motto of build, launch, iterate. So we really, really focused on deploying our code as quickly as we could and pushing out features as fast as we could. Now, this was a case where we were really looking to validate the use case of this product. And so therefore, speed became much more important versus the longevity, the high level scalability, things like that of the application. Now, in the past at the security company that I work for, this was not the case. We focused on quality over speed. But particularly with Studio, we were able to focus on speed primarily. So secondly, use a design library. This will help you build quickly and will reduce friction between the designs that you get and the engineering effort. Now, I think I forgot to mention, there were 2 engineers on this project and 1 designer, all building this application. So we had a small team and 1 PM. So we had a small team, but we were small but mighty. And we had to find ways to reduce friction between each of the disciplines so we could deploy quickly. We used a couple tools. We used Zeppelin primarily for the designer to developer pass-off. This allowed us to easily pull images and get code attributes and things like that. And then we had a shared design library that we used both on the sketch side as well as in the code, which was Material UI. Third, prioritize. Be intentful about saying no. This might be hard because there's a lot of new technologies and new cool things that are fun to kind of play around with, but we had to be really diligent about saying no. So some of the things we did prioritize was user experience and user interaction. We wanted that to feel really, really polished for our end users so they could accomplish what they were trying to in this application and find great collaborators and have a general feeling of fulfillment from this application. And things that we didn't focus on was a lot of high complexity integrations or a ton of code coverage beyond what was necessary to know that the app was running well. Fourth, default to simplicity and speed. We relied heavily on Firebase as a platform. We used Firebase Auth, Firestore, as well as deployed our code using Cloud Functions. We also used Next.js, which handled a lot of the server-side rendering for us, and also handled a lot of the routing and things like that. So we relied heavily on the tools that we chose to help us move fast. Fifth, offload DevOps and use serverless. Kubernetes and Docker are awesome. We all want to use them, but if you're trying to build as quickly as possible, serverless is the way to go, and especially for something that's not a crazy complex application where you need a bunch of microservices, serverless is super simple. Since we were using Next.js, we set up a simple function that served our entire application. And this is the Cloud function. You could see the code here that deployed the whole app to our Cloud functions. So in conclusion, focus on outcomes, use a design library, prioritize your tasks, and know what you're saying no to. Talk to your team about that, that's critical. Simplicity and speed are the name of the game, and offload DevOps, serverless is your friend. That's all. I think I'm actually a little bit over time, but thank you all for listening, and I hope you gathered some quick tips on how to build software as fast as possible.
Hi everyone, my name is Daria Caraway, and in this lightning talk, I want to show you a couple of tips for debugging web apps with the Chrome DevTools. A little bit about me. I'm a Boulder native currently working at Workday as a software engineer here in the Boulder area. The Chrome DevTools features I want to show off today are the ability to set conditional breakpoints, which allow us to only break if a certain criteria is met, as well as DOM breakpoints, which allow us to break when a certain DOM element changes. And lastly, I want to do a little bit of event investigation where we will inspect and manipulate event listeners straight from inside of the browser. So first off, I want to show you how conditional breakpoints work. I have this little demo, and right now, when I click this button, I expect something to show up on the screen, but what's actually happening is when I click this button, I get a big error. So I'm going to go ahead and take a look at what's going on. I can see the error happening in the console. I'll go ahead and click on it, take me to the file. So I can see that I have this click handler, and when I click it, I have a bunch of inputs coming from somewhere that I don't necessarily control, and if any of those inputs are greater than 10, then an error gets thrown. Now, I'm mostly interested in the input that's causing the error to be thrown, and so you could definitely do this with a console log and log them to the console, but I want to take a look at what it might look like if we use the debugger. So I'm going to go ahead and add a breakpoint here and run the example, and you can see that I'll hit this breakpoint for every single input. So the first input is 1, it's not greater than 10, should be okay. And then 2, no error. 3, then 4, then 5, and 6, and maybe there are thousands of these inputs, and I don't really want to have to click this button for every single one until I see one that might throw an error. So what I'll do instead is I can right-click on this breakpoint and say Edit Breakpoint. And here I can add a condition. So I want to say that this breakpoint should only be hit if the input is greater than 10. And the next time I hit this play button, the breakpoint will only be hit for an input greater than 10. So in this case, 100 is the input that is throwing the error. And now I can go through my code and my inputs and try to figure out where 100 is coming from. Next, I want to show you how to set a DOM breakpoint. So I have another example here, and when I press this button, I expect great content to be changed to new great content. But right now when I press this button, something really weird happens. So you'll see something flash really, really quickly, and then all of a sudden the wrong content is on the page. I'll do it once more because it's very quick. Click this button. something flashes and all of a sudden we have the wrong content, and it's really hard to figure out what's going on. So what I can do is I'll go ahead, inspect this whole area, and I'm going to click these three dots here and say break on subtree modification. So what this will do is if any part of the subtree underneath this DOM element changes, my breakpoint will be hit. So I'm going to go ahead and run my example again. And you can see this time we've hit a breakpoint. Something is being removed from the DOM. Great content is being removed. That's good. Something is about to be added now. So I can see that new great content is actually being added to the DOM. And then if I press play, it gets removed all of a sudden, which is kind of weird. And once more, then the wrong content gets added. So with these DOM breakpoints, we can see that new great content is being added, but something is coming after and replacing it. So maybe I can use that to focus my debugging efforts. Maybe it's not the file that's adding the content. I have to look at something that's happening afterwards. Lastly, I want to show you some event investigation. This is something that I didn't realize was part of the Chrome DevTools for a long time. And if you're debugging some nasty event bugs, it can be really, really useful. So I have another example, and when I click this button, I expect something to be logged to the console. But right now you can see the little button ripple. When I click it, nothing is happening, nothing being logged to the console. So what I can do is I can inspect this button. Here is my button, and I can go over here and click event listeners. And this is a list of all of the possible event listeners that can be registered for this button. If I open up click, I'll see all of the click handlers that are registered for this button. There's one at the top level that React puts there. And here is the click handler that I'm expecting to fire for this button. You can get some information about it. It's no op because all it's supposed to do is console log. Now, browser events are a little bit complicated, but essentially, if anything underneath this DOM event is also capturing that event and then preventing it from further bubbling up the tree, we can see this behavior where my event handler here is never actually being called. So I'm gonna walk down the tree and see if there are any other offending event handlers. So nothing here. This is still the one that I'm expecting to fire. But when I click on this div, there is in fact another event handler. And if I open it up, I can see that this handler is calling to stop propagation, which is going to make it so that the event doesn't continue to bubble up the chain, propagate up the chain. Now, if I want to double check that this is the event handler that's capturing the click I'm expecting, I can go ahead and remove it straight from the DevTools. And now when I click this button, you can see that my event handler that I'm expecting is firing. So it's really handy to be able to inspect those event handlers straight from the DOM and not have to change your code. And maybe you have event handlers coming from everywhere, and if you have a really big code base, it can be difficult to see the structure of your DOM from the code itself. So it's nice to be able to see it here and just investigate them straight in this panel. So hopefully next time, if you have a really sticky bug and you're not sure where to start, maybe one of these cool Chrome DevTools features can help you out.